So you want to solve the following system by substitution. And the idea behind solving this by substitution is that you're going to take one of these equations, solve for a variable, and then substitute into the other equations until you get the solution for both x and y that would make this system, those two equations, true at the same time. Now, what you want to do is you want to look at each equation and you want to look at each term. So if you look at this term here, the coefficient of this term is -7. The coefficient of this term here is -2. The coefficient of this term here is 1. Remember, there's no number there, so it needs to be a 1. And the coefficient of this term is -2. The easiest kind of situation is where the coefficient is 1, and that's what we have here. We have a coefficient of 1. So what you want to do, the most efficient way, is to take this equation, the second equation, and solve for the variable x because that coefficient is already a 1. So with substitution, you want to take an equation and solve for a variable. And you want to do it in such a way, if possible, it's not always possible, but if possible, you want to do it in such a way to where you don't involve any fractions. And so if I can solve for the variable x here, I'm not going to involve any fractions. You see, if you went here, right here, and let's say you want to solve for the variable x, notice that at some point you would have to divide both sides by -7, which would involve fractions. And you can do that, it's just that you have to be very careful when you're dealing with fractions. So in this case, it is easier just to get the variable x by itself for the second equation. So I'm going to go ahead and solve for x here, and so I get x equal, now remember this is -2y, so I'm going to have to add 2y to both sides, so I'm going to get 2y plus 11. So when I solve for the variable x, I get 2y plus 11. I'm going to take this, now the next step is to take this expression here, 2y plus 11, which is equal to x. I'm going to substitute it into the other equation in place of x, because that's what x equals. So x equals 2y plus 11. So I'm going to get this. I'm going to get -7 times, in parentheses, because -7 is multiplied by all of this expression right here, 2y plus 11 minus 2y equal -13. And so notice I have a linear equation with just one variable, the variable y. So if I can solve for the variable y, I will have found the y coordinate of the solution to this system. All right, so I'm going to have to use the distributive property. So I get -14y, and a -7 times 11 is a -77, minus 2y equal -13. The next step is to combine like terms, which I can. A -14y and a -2y is a -16y, minus 77 equals a -13. Adding 77 to both sides, combining like terms, I'm going to get -16y is equal to, let's see, that's going to be 64. All right, so 64. And then dividing both sides by -16 to get y by itself, because -16 divided by -16 is 1. 1 times y is y. And so 664 divided by -16 is going to equal -4. All right, now what that represents is that the solution to the system, my y coordinate, is -4. Now I've got to find the x coordinate, because remember this solution is a point, so you have an x coordinate and a y coordinate. Well, if you look at this now, if you got to be careful, you got to make sure you've done this correctly. So if you solve for the variable x correctly, you didn't make any mistake on this side, then all you really have to do is just go back to this equation here, and where we see the variable y, you're going to substitute -4. So I get over here, I'm going to get x equal 2 times y, which is -4, plus 11, and so 2 times a -4 is a -8. A -8 plus 11 will give me 8, 19, 11 will give me +3. So I found the solution. So the solution to this system is, remember, you've got to write it as an ordered pair. So x is 3, y is -4. So that's the solution. And you can always check your work, but let's check and see if this is correct. So to check it, you have to go back to the original, these two equations, and where we see the variable x, you're going to substitute 3. Where we see the variable y, you're going to substitute -4. And basically what better happen is that the solution here better satisfy this equation and this equation at the same time. And so I'm going to get -7 times x, x is 3, and then -2 times y, y is -4, and I want to see if that's going to equal a -13. So -7 times 3 is a -21, a -4 times a -2 is a +8, and the question is this equal to a -13? And the answer is yes. All right, now let's go to the second equation. So the second equation, x minus 2y, so that's your first equation. So the second equation, so x, which is 3, minus 2 times y, which is -4. And again, you want to see that's going to equal 11 in this case. So I get 3, a -2 times 4, a -4 is a +8, and 3 plus 8 is equal to 11. Okay, so that's number 1. Okay, number 2, let's suppose we had this equation. So number 2, the equation is this. It's -2x minus y equal -9, and then 5x minus 2y equal 18. Now, the thought process in this one, again, you want to do this by substitution. The thought process in this one is this. Is there an equation you can choose that you can solve for one of the variables and you're not going to involve any fractions at all? And so if you look at the second equation, if you ask yourself, I'm going to pick the second equation and solve for y, I hope you realize that you're going to have to divide both sides by 5. I'm sorry, solve for x. You would have to divide both sides by 5, and you would involve fractions. Same thing for y. You'd have to, at some point, divide both sides by -2, and you would have, in this case right here, a fraction for the coefficient of x. So that is not feasible, although you can do that, and you will get the correct solution if you don't make any mathematical errors. But I want you to notice that equation 1, the variable y. See, the variable y here, the coefficient is -1, so you can easily solve for y. So let's go ahead and do that. Let's go ahead and solve for y. Now, I need to be a little bit careful because that is not a positive y, that's a negative y right here. So when I solve for y, let's think about this. I'm going to rewrite the equation over, and I get this. Now, there are two ways you can think of this. You can think of this in this way as well, in two ways. So one way is I'm going to go ahead and add y to both sides, just like this. That's one way. And I get -2x when I combine like terms. I get -2x equals y minus 9. And then all I have to do to get y by itself is add 9 to both sides. And so I get y equals -2x plus 9. That's one way. The other way is this. Let's think about this. All right, so I'm going to go ahead and rewrite it over. So that's what we had. And so what some students do is they're going to add 2x to both sides, which is fine. That's perfectly fine. You can do that. But you got to be careful. You don't get y. You get -y right here. So this is 0, and you combine like terms. You get -1y. I'm going to go ahead and write this -1y equal 2x minus 9. That's what you get. But remember, you're trying to get y by itself, so you can substitute into the other equation. So if I get y by itself, I've got to, let me go ahead and rewrite this over. I've got to divide both sides by -1. That's what you have to do. And so -1 divided by -1 is 1. 1 times y is y. And you need to be careful here because these two terms are being divided by -1. So what you have is this. 2x divided by -1 is a -2x. A -9 divided by -1 is a +9, which is what you have here. So notice the two ways. It's a good idea to understand those two ways. So that way you can determine which for yourself is more feasible for you. All right, once you solve for y, then I'm going to take that and substitute into the other equation. So I'm going to get this now. I'm going to get 5x minus 2 times y. Y is -2x plus 9. And that's going to equal 18. Now notice I have a linear equation with just a variable x. I can easily solve for x. So I get, now I have to distribute here. So I get 5x, a negative 2 times a negative 2x is a positive 4x. A negative 2 times positive 9 is a negative 18, and that's going to equal 18. Combining like terms, I get 9x minus 18 equals 18. Adding 18 to both sides, I get 9x equal 36. This is 0 and I combine them. That's 36 on this side. And then finally get x by itself and divide both sides by 9. Reduce over here, I get x. 9 divided by 9 is 1. 1 times x is x equal 4. So I get an x coordinate of 4 in this case. To find the y coordinate, I can go back to this equation here. Now you got to be careful because you got to make sure that there was no error here. So at the end, if you do this, at the end, always check your work. Always go back to the original equation, make sure it does work, because you could easily have messed up here. All right, so then let's go ahead and solve for y. So y equals negative 2 times x, x is 4, plus 9. Negative 2 times 4 is a negative 8. Negative 8 plus 9 is a positive 1. So I'm saying that my solution, and you got a rise in order pair, so your solution is 1, 4. I'm sorry, it is 4, 1. Excuse me, so you got to be careful. X is 4, y is 1. All right, now let's check this because I could have made a mistake here or I could have made a mistake here. So I just got to make sure that what I have here actually works. So if I substitute 4 for x, 1 for y, both those equations better be satisfied. All right, so let's check. So let's go back to the first one. Negative 2 times x, x is 4, minus y, y is 1, and I want to see if that's going to equal negative 9. That's what I want to look for. Well, negative 2 times 4 is a negative 8. Negative 8 minus 1 is a negative 9. So that's true. All right, let's do the other one. 5 times x, x is 4, minus 2 times y, y is 1, and I want to see if that's going to equal 18. That's a question. Well, 5 times 4 is 20. 2 times 1 is 2. Is 20 minus 2 equal to 18? The answer is yes. So that works. All right, so that was number 2. Number 3, you have this. In number 3, you have this system. Negative 2x plus 6y equals 6. Negative 7x plus 8y equal negative 5. Okay, now in this particular situation, you have, if you look at all the coefficients of the variables, none of them is 1. None of them is 1. None of them is even negative 1. They're all something other than 1 or negative 1. So again, you want to make sure, you want to see if it's possible. Is it possible to pick a variable, to solve for a variable, so that you don't involve any fractions at all? Well, let's see. So for example, if I look at the second equation, if I solve for the variable x, I would have to at some point divide by negative 7, which would involve fractions. 8 divided by negative 7, negative 5 divided by negative 7. Same thing over here. If I choose the variable y, let's say, divide everything by 8, you involve fractions. Now if I go to the first equation, if I solve for y, notice I will involve fractions also, because over here that will be a negative 2/6, which is a negative 1/3 reduced. But if I look at x right here, you see these two numbers, 6 and 6, they're both divisible by this negative 2. So what the best thing to do here is to pick the first equation and solve for the variable x. All right, so I'm going to go ahead and rewrite this over, and I get this. All right, now to get x by itself, I'm going to go ahead and, again, there are several ways you can do this. I'm just going to go ahead and bring the 6y over. So I'm going to have, remember, you're really subtracting 6y. That's what you're doing. So I get negative 2x equals 6 minus 6y. That's what you get. But remember, you got to get x by itself. So I'm going to have to divide both sides by negative 2. So negative 2 divided by negative 2 is 1. 1 times x is x. And just like we did a while ago, these two terms are both being divided by negative 2. So 6 divided by negative 2 is a negative 3. A negative divided by negative is a positive over here. So negative 6y divided by negative 2 is a positive 3y. So be very careful when you get to this point because at this point right here, you could mess up with your signs as well. All right, once you solve for the variable x, you go to the other equation. So that'll be the second equation here. Wherever you see the variable x, you're going to substitute this expression. So I get negative 7 times negative 3 plus 3y plus 8y is equal to negative 5. Distributing, I get a negative 7 times a negative 3 is a positive 21. A negative 7 times a negative 3y is a negative 21y plus 8y equal negative 5. All right, now at this point, we're going to combine like terms, and when I combine like terms, in this case, the terms that involve y, I get 21, a negative 21y, and a positive 8y is a negative 13y, and that's equal to negative 5. All right, now, remember this is a linear equation, so I'm going to subtract 21 from both sides. And so combine like terms, this is 0 now. So I get negative 13y is equal to a negative 26. A negative 5 and negative 21 is a negative 26. To get y by itself, I'm going to divide both sides by negative 13. The coefficient, negative 13 divided by negative 13 is 1. 1 times y is y. And so a negative 26 divided by negative 13 is a positive 2. So that's the y-coordinate of your solution. All right, to find the x-coordinate, let's go back to this one. Now again, you could have easily messed up, but at the end you're going to check your work. You're going to check to make sure it does work out. All right, so I get x equal negative 3 plus 3 times y. Y is 2. And so I get negative 3 plus 6, and negative 3 plus 6 is 3. So my x-coordinate of the solution is 3. So my solution is, remember, the ordered pair x, y is 3, 2. But again, I could have messed up, so don't say that's your solution without going back and checking it, because I could have messed up anywhere along the way. So let's just check it. It's easy to check. So let's check the first equation. Negative 2 times x, x is 3. So I'm checking over here. So negative 2 times 3 plus 6 times y, y is 2, and I want to see if that's going to equal 6. Well, negative 2 times 3 is negative 6. Negative 6 times 2, positive 6 times 2 is a positive 12. Negative 6 plus 12 is equal to 6. Now let's check the other one. Negative 7 times x plus 8y equal negative 5. So negative 7 times x, x is 3, plus 8 times y, y is 2, and we'll see if that's going to equal a negative 5. Negative 7 times 3 is a negative 21, 8 times 2 is 16, and a negative 21 plus 16 is equal to a negative 5. So that's your solution. All right, and then number 4, you had this. So 4, you had y equal negative 3x plus 4, and y equal 4x minus 10. All right, now for some reason this confuses students because they see that y is both equal to different expressions and they don't know what to do. Well, remember, you're solving the system by substitution. So if you look at this equation here, the first equation, well, it's already solved for y. Over here, if you look at this equation, it's already solved for y. So both these y's are equal to two different expressions. So y equals this and y equals this, which means that these two expressions have to be equal to each other. So for example, let's say you took the first equation and you solve for y. Well, it's already by itself, so you get y equals negative 3x plus 4. But remember, the next step is to take this expression here and in place of and go to the second, and wherever you see the variable y, you substitute that. So you get negative 3x plus 4 equal 4x minus 10. All right, and you just solve this linear equation for x. So I'm going to add 3x to both sides. And so when I combine like terms, I get 4 equals 7x minus 10. Adding 10 to both sides. Combine like terms, I get 7x equal 14. And so x is 2. That's your x-coordinate, your solution. to find the y-coordinate, it didn't matter. It didn't matter which one you went to because both of them were easy to solve for y. So for example, you see this x equal 2. If I go here, negative 3 times 2 is a negative 6. Negative 6 plus 4 is negative 2. Over here, 4 times 2 is 8. 8 minus 10 is negative 2. So regardless of which one I use, I get the same y-coordinate. So it did not matter. So I'm going to go here, and in place of x, I'm going to substitute 2. And so I get negative 3 times 2 is a negative 6. Negative 6 plus 4 is negative 2. So my solution, your solution as an ordered pair, is x is 2, y is negative 2. Okay, but let's check. I could have easily messed up anywhere along the way. So let's go back to the original, and check your work. So let's check. So I get y equals negative 3x plus 2. So y is negative 2. So I'm going to write negative 2. And I'm going to see that's going to equal negative 3 times x. X is 2 plus 4. All right, over here, I get negative 6 plus 4. And the question is negative 6 plus 4 equal to negative 2? And the answer is yes. All right, look at the other equation. Y equals 4x minus 10. Y is negative 2. So negative 2, I want to see if that's going to equal 4 times x. X is 2 minus 10. Well, 4 times 2 is 8. And the question is 8 minus 10 equal to a negative 2? And the answer is yes. Okay, so that was a quick review of solving a system by substitution.